Hello everyone, and welcome to the operations lecture. In this lecture, we're just going to review some of the most important operations for pandas, as well as learn some useful operations that we haven't gone over yet. Let's go ahead and jump to the Jupyter Notebook to get started. Alright, here I am at the Jupyter Notebook. I went ahead and just copied the first cell of the operations notebook that goes with this lecture in order to create this data frame. It just has 3 columns, call 1, call 2, and call 3, and it has an index of just numbers, 0, 1, 2, 3. In call 1, we have 4 digits. In call 2, we have 4 numbers here, but notice that 444 is repeated, and then in call 3, we just have 4 sets of strings. Let's talk about finding unique values in a data frame. There's 3 main useful methods concerned with finding unique values in a data frame. Imagine we wanted to find all the unique values in column 2. The method we can use for that is just the unique method. And this will return a NumPy array of all the unique values in column 2. Instead of actually wanting the array of unique values, let's say you just actually want the number of values itself. Well, there's 2 methods for this. You could just check the length of the array that gets returned, and this would respond to 3. There's 3 unique values in column 2. But Pandas actually has a built-in method for this, and it's just n unique. And if I run this cell, I get the same answer. Alright, so we have unique for actual returning an array of unique values, and n unique if I want the number of unique values. The last useful function I want to show you is value counts. And this basically means if you want a table of the unique values and how many times they show up. You can just use value underscore counts as a method, run this, and this returns how many times each unique value occurred in that column. In this case, 444 occurred twice, and the other numbers occurred 1 time each. Alright, those are 3 very useful methods, and you'll find yourself using them often in the exercises. Let's go ahead and talk about selecting data. We've already gone over conditional selection, but I want to re-emphasize just how important it is and how powerful it is as a tool. We have our data frame, df, and we can use conditional selection by passing in a conditional selection statement, such as saying, return the df where column 1 is greater than 2. And this will return all the rows of the data frame where column 1 happened to be greater than 2. And remember that this command inside is essentially just a Boolean series of false, false, true, true. Now, as a quick reminder, if you want to combine conditions, you can wrap these conditions in parentheses and then use either an ampersand or a pipe operator, depending if you want and or. And then you can say another condition, such as where call 2, let me pass this in as a string, has equality with 444. And this should return just that last row, 3. And there it is. Okay. That's just a quick reminder of how to select data using conditional selection. Now let's talk about the apply method. The apply method is going to be one of the most powerful tools in your tool belt when using pandas. So let's go ahead and show you how it works. Imagine we have a function, def times 2, that takes in a value x and then returns, let's say, x times 2. Alright, a very simple function. Now, you know that you can already grab, for instance, a column and call a built-in function off of it, such as the sum. And that will return the sum of the column. But what if you wanted to apply your own custom function, such as times 2? Well, Pandas has the ability to do that. You can just say the column name, and then .apply, and then you just pass in whatever function you want to apply. In this case, we're going to go ahead and apply times 2. And this will broadcast that function to each element in that column, 2, 4, 6, 8. You can also apply built-in functions, such as length. For instance, if we take a look at column 3, we had a bunch of strings. Let's say we wanted a column that represented the length of each string. Well, then we could just say apply and pass in len. And that returns the length of each string, which in this case was 3 for all of those strings. Apply is going to be especially powerful when you combine it with lambda expressions. That way, you don't need to take the whole time to define an entire function if you're just going to apply it once. For instance, let's go ahead and make a lambda expression out of times 2. I'm going to go ahead and say lambda x colon, and then just x times 2. And I'm going to apply this to column 2. Let's go ahead and see how this works. And there you have it. We were able to multiply each value in that column by 2. And we were able to do this without having to write an entire function for it. We just did this as a lambda expression. And this is the sort of thing you're going to be using all the time as you get more and more comfortable with pandas. This is probably one of the most powerful features of pandas, the ability to apply your own custom lambda expressions or functions. All right, let's talk about removing columns. Again, if we have df, we want to, let's say, remove column 1. We can just say df drop, pass in the column we want to drop, col1, and then remember, since it's on the columns, we have to specify access is equal to 1. And this will drop that column. If we want this to occur in place, we'd have to specify in place equals true. Let's go ahead and not run that so we retain our original data frame. If you want to get the column and index names off a data frame, those are actually just attributes of the data frame itself. Meaning you can say df columns, and it'll return this kind of index object, which is essentially just a list of column names. This is going to be especially useful when you're trying to index a column and maybe the spacing is weird or you can't quite figure out what the string is. You can just call df.columns or whatever your data frame name is, and it will return this list of column names. And you can actually do the same thing for an index. You can say df.index and it'll give you information of the index. In this case, since it's a range index, it actually just reports back the start, stop, and step size of the index. All right. Let's talk about sorting and ordering a data frame. Here we have df, and imagine we wanted to sort it by column 2. Essentially, we want 444 and then 444 again before we see 555 and 66. We can use sort values in order to do this. You call df sort underscore values, and then as an argument, you say by. And we check Shift Tab here, you can say by, and you can order this off of either the rows or the columns. But essentially, you just pass in, as an argument, the column you want to sort by. So I want to sort this by column 2, and you can say just column 2 as such, Shift Enter, and now I've sorted this data frame by column 2. Note how the index stays attached to the row, so you don't ever lose that information there. And that's the same thing as just saying by column 2. It's the same thing because it expects by to be the first argument. All right, let's talk about just a couple more useful operations. A really useful method to find null values in your data frame is the df is null. And this will return a data frame of booleans indicating whether or not the value was null or not. In this case, we get a boolean of all falses because we have no nulls in our data frame. All right, now let's finally talk about one last function or method in pandas called the pivot table. And this methodology will be really familiar for advanced Excel users. I'm going to go ahead and copy and paste some code from the notebook to create a new data frame. If we go ahead and check out this data frame, we have something that looks like this. We have A, B, C, and D columns. And notice here that we have repeating values in both the A column, the B column, and the C column. So A column has foo's and bars, B has 1, 2's, C has x's and y's, and then D has some integer values. You can use df.pivottable to actually create a pivot table. And if you're not familiar with pivot tables, I wouldn't worry about this too much, but if you are maybe an Excel user who is familiar with pivot tables, hopefully you'll find this functionality useful. Basically, what we're going to do for non-Excel users is just create a multi-index out of this table or a data frame. The method to do this is pivot underscore table. And pivot underscore table takes in 3 main arguments: the values, the index, and the columns. In this case, let's go ahead and indicate that the values we want in our table are these D values. This is what we actually want the data frame data points to be made up of. So I'm going to say values is equal to the D column, and then I will set my index to be equal to the A column and the B column. And that's basically going to make A and B into a multi-level index. So I'm going to pass in a list then, since it's more than one column, of index A and B. And then finally, I want my actual columns to be defined by the C column. In this case, just C, then I'm going to pass that in as a list here. And note that I'm saying C is going to be the column, so I should end up with a column for X and a column for Y. Let's go ahead and see how this works. I'm going to run this one more time here so we can compare the original data frame versus the pivot table that I'm about to create. Alright, so I ran this pivot table command, and let's go ahead and compare the two. Looks like I created an index out of those A and B columns, so that makes sense. Looks like we have bar and foo, and then 1 and 2 repeated. Then, the actual columns I wanted were the C values, in this case just X and Y, and the actual data point values were the D columns. Note, I do have some null values here because there were no values that matched up for that specific point. Meaning, if I look back at the original data frame, there is no value that goes with bar to X. So if you look here, you won't find bar to X, you'll only find bar to Y. And similarly, for foo to Y, there is no foo to Y, there's only foo to X. And that's why we had to fill in null values here. Okay, feel free to post the Q&A if you have more questions on pivot tables or want some more resources for examples on pivot tables. We won't really use these that often in the course. In fact, there's only really one exercise question later on when we're working with heat maps as far as how to use the pivot tables. But for now, only concern yourself with them if you're already familiar with pivot tables from something like Excel. Okay, I hope some of these operations were useful to you. It's basically just a grab bag of useful functions and methods that are available to you in Pandas. You can go ahead and reference the Pandas operations lecture notebook that's underneath the Pandas folder. Thanks everyone, and I'll see you at the next lecture.